All right, we got 70 people in the session. This is pretty awesome.
Yeah, we have set up a Google Doc, which basically will be our agenda for the session. So I shared that in the chat.
And also in the shared screen.
Yeah,
so I'll be I'll be scrolling it while we'll be going to the topics.
That'd be great. So the first topic is Xdp multibuff. And I put Lorenzo, he's sending the patches to the mailing list.
Hello, can you hear me?
Yeah.
Okay. Actually, we inserted this topic in the agenda in order to discuss or let's say to have a broader discussion about the opening points that we are discussing upstream regarding this functionality. And let's say to summarize, Xdp multibuff is wants at least try to overcome the current limitation that we have nowadays with Xdp, where we have a memory model where, let's say, most of the times we have, let's say, a single buffer. We have, let's say, the packet must be lower than the page size in order to overcome some limitations and to not have performance hit. So we are trying to implement a solution that at the same time can overcome this limitation. So having, let's say, a packet size, support jumbo frames, so have a packet size bigger than the MTU and bigger than a single page, but at the same time avoiding to hit performances on the, let's call it in the legacy case where we have, let's say, a single buffer lower than the MTU. I think that there are some slides in the presentation that we had in the last Netdev Conf, and the main idea behind the solution is to insert an SKB shared infrastructure at the end of the first buffer in order, let's say, to link together all the other buffers that compose the frame. And we are currently discussing the advantage of the benefit, the upside of this solution is will allow, for example, to receive, for example, to support TSO with Xdp, and even the goal is to support GRO in V8 or, for example, in CPU maps that nowadays are currently not supported. So in the subtopic we summarized what are the open points that we have upstream nowadays, and more or less the first issue that we encountered that is in the current code base, let's say 99% of 100% of the time in the eBPF program, in order to calculate the packet length, we do the difference between the data end pointer and the data pointer. And with the Xdp multibuff, this will not be no more valid, because Xdp data, in the Xdp data at the end will just point to the first buffer, to the first segment that compose the buffer, right? So we need to find a way to, let's say, calculate the real packet size in this case. And in a series that I posted upstream, one possible the approach that I suggested is to use an eBPF helper that take into account if this is a real Xdp multibuffer or not, in order to check if this is in order to report to the eBPF program the real size of the packet at the end. Yes, this is the presentation that we had last year at the Netdev Conf, And I think, please, if you, yes, this is actually the architecture of the buffer that we are proposing, where, for example, where we can see that at the end of the first buffer, we have this Xdp shared infrastructure that allow us to link together all the subsequent buffers that compose the frame. And here we can see even the problem that I was describing, because as you can see, data at the end actually point to just to the first buffer. So if we do, in order to compute the length, if we do data at the end minus data, this is not correct. So this is the first, let's say, open topic that we would like to discuss in order to, let's say, get more opinions about it. And I don't know if you want to discuss this in the chat or whatever, to discuss it topic by topic, or if we summarize all of them and then we discuss about them. What do you prefer?
We discuss it.
It looks like Alexander has raised his hand, so he wants to somehow join the session. Can someone?
Yeah. Okay. He is now on stage.
Yeah.
Hi, Alex. I know Lorenzo disappeared.
Yeah, but Lorenzo got kicked off now.
Yeah. Hi, Alex.
Alex, it looks like you're speaking, but I cannot hear you.
Yes.
I'm not hearing you.
So while Alex is under his setup, I'll try to sound the question that Jesse's raised. Why not just use scatter gather list? Is it simpler than data structure than Xdp shared info? And my opinion is to have a simpler conversion when we have to convert our Xdp buffer into the SKB. So
yes, this is exactly the reason that why we decide to go along this road. Because whenever we, let's say, we need to convert the Xdp buffer or the Xdp frame into an SKB, we don't need to reset all the fragments, but since they are at the same position and they are not, let's say, overwritten, it's just it will be for free, let's say.
So should we try to see if Alex can speak? No, I'm not hearing you. When I logged in, there were several options of selecting different speakers, and it apparently reported that I had 5 speakers in my system, which was a little bit surprising to me. Oh, actually, it's not.
Alex, can you hear me? You're on mute right now. You can hear me, but just raise your hand if you can hear me. But okay,
Yeah.
You're unmuted. Maybe get out and then come back in. Oh, it's your headphone. Okay.
So was there any other questions that came up in the conversation? No, not yet.
Maybe we can proceed in the meantime, and then we can come back to the question, to the discussion, let's say. I don't know.
Sure. I mean,
good
Alex
idea.
will start making noise when he gets ready.
Yes. And so it was okay. Okay, then I think so. This is the first, let's say, open point about the discussion, and another point, let's say, that we are currently discussing upstream about the solution is let's say, people upstream requested the capability to let's say access each fragment that available in the buffer, and even store values inside each buffer in arbitrary frame. So we are, let's say, discussing upstream what could be useful APIs, for example, for some helpers in order to perform this. John Fasterbend proposed some possible approach upstream, and actually, as far as I remember, what he's proposing is not, I think is not listed here, but is more or less, he was suggesting, let's say, to use the data in data pointer, and let's say as a sliding window, and set them in the proper fragment you want to modify it inside with the BPF program without touching any without doing any special change in the verifier, because it should be supported, and then reset the values back. But let's say this is just a possible approach, and let's say we are open to any other possibility about this.
Yeah, we have one question from Martin. So drivers need to increase the receive buffer length to make room for SKB shared info? Not exactly, because I think 99, if not, yeah, Jesper, you're right. All the drivers that support XDP, they already reserve
yes.
A memory for SKB shared info. And as far as I know, this like XDP shared info will not be bigger than SKB shared info, so it's fine. It won't increase anything.
Yeah.
No, exactly. The space is already, is already reserved, and they changed that reserve this SKB shared info area is already merged. We are just, let's say, leveraging on this new area in order to add this feature.
Yeah, and I also hope we can basically be more compatible with the SKBs, as this is the same area. So once we want, if you are on a certain point in time want to convert the SKB frame into an SKB, we would have to do less work of converting this over. That's why I want to keep it somewhat compatible with the layout.
Yes. Actually,
I would have loved to hear about Alexander's input on this, because he's the expert in this area.
Which Alexander's input?
Not the other Alexander, Alexander Dyke.
Okay, yeah.
Who was trying to speak but couldn't.
So I've been watching for this mainline discussions for a long period of time, but I think I just missed the latest thoughts that were here in lore for the past 2 maybe weeks. So what is the current problems in this multi-buffer setups? Because it's a long-term topic, right? It's more than a year, I think, since the first.
Yes.
Yeah, I think it's mostly topic 2 and topic 3 are sort of the blockers, right? So we are hand-waving around how we can be backward compatible. Jamal, could you invite Toge to the session? And Toge wrote an email about that, how different proposals that we would like to get some input on.
Yeah, Toge, have a raised hand.
Yeah, and the other the other topic which is really blocking is how do we access the payload data in the fragments? And there's a lot of different opinions about this, and I think that is what mostly is blocking the pad set. So for topic 3, I actually wanted to propose that we simply don't in the first iteration of the pad set, we simply don't give access to the other fragments. We only give access to the first fragment, and then just add a length function that you can get the length of the entire packet, but don't give read access to the bits or write access to the bits. But I think it's difficult to get a conversation going on this platform about that.
Hi, Toke.
Hello. Yeah, on the backward compatibility thing, I tried in the email that's linked, I tried to summarize the different options. So first off, like the problem with backward compatibilities is mostly that like the way we're implementing multibuf now is we could just do nothing and let programs continue to run. And that would work from the kernel's point of view, but it might introduce subtle bugs into the Xdp programs in that if you're trying to compute the length of the packet, you will get the wrong value because you will only get the length of the first fragment, or if you think you're passing the whole payload, you're only passing part of it. And so I think I summarized 3 different options for how to fix this. The first one is just to do nothing and let programs break and let the user worry about it. Don't load an MB unaware program on an MB configured system. Otherwise, you'll get to keep all the pieces when it breaks. The other one is have a dynamic check at runtime and drop packets if the program is not MB aware, which is probably not great because it has runtime overhead. So I think that was mostly included for complete to get everything in there. And then the third one is reject loading of multi-buffer aware programs. All of this sort of presupposes that programs can declare themselves multi-buffer aware, which is like you can set a flag in expected attached type when you load the program. So that's sort of fine. And even the loader can override this like with a force load thing. So assuming we do this, the only problem is when do we reject loading the programs? Because we can't just do it on a per device level because you can have redirects. So you may have multi-buffer aware packets, frames with multiple segments may be redirected to, say, a VF device, and then you'll have it on a different NIC, even though that NIC is not maybe MB aware. So if we're going to reject it, it sort of has to be global. And then the problem then becomes, how do we do that? One option is try to do it dynamically, like the first time you enable any driver, set any driver to MB mode somehow, we will start rejecting MB aware programs. The problem with this is that it may not be obvious to the user that they are then enabling multi-buffer programs, right? It's like, I'm just increasing my MTU. Why is Xdp suddenly refusing to load? So that might not be a good user experience either. So, and we can't do, I think, Yuri put a comment in the document which says we could switch off multi-buffer when loading such a program, like going the other way. And the problem with this is then we need to, like when you load an Xdp program, you need to enumerate all devices in the system and potentially start changing the MTUs. And that's not going to be a great experience either, I think. And so I think like the least bad option we actually came up with is a global SIF control, which toggles the MB support. So distros can then turn that on by default, and then you will just have to load your Xdp programs as multi-buffer aware. And if you haven't flagged this in the program source code, then you can have your user space loader set this flag when loading the program if you know that it doesn't matter, like if it's not counting the packet size or anything like that. So I think, as far as I'm concerned, that is the least bad option, and I'm not sure if it's better or worse than doing nothing.
Well, to some extent, I think for a lot of the NICs, we're already seeing. Can you guys hear me this time?
Yes, we can hear you.
Yeah. So I think for a lot of the NICs, what we're seeing is you enable jumbo frames, or you change the MTU, and you're already locked out of Xdp in most cases. A lot of them are already set to do that. So that kind of behavior is kind of already an existing issue that we have. And so if nothing else, I see this as being a means of working around some of that. So you enable this, and now you're switched into this other mode. So it's either we could go with the mode approach, or it just becomes something where, okay, if you enable, a jumbo MTU, you're just gonna have to go back, and if we do the syscontrol approach, it's gonna be legacy behavior where we disable explicitly, or you switch into this new mode. It's gonna be one of the two is what you're kind of stuck with. So there's kind of some gray areas in between for some of these in terms of how we'll get the compatibility to work.
Yeah, so I think things are definitely going to break in interesting ways, right? As soon as you have this.
Right.
So I think whether or not we do this mode switch is only if how it breaks. And I think there may be a benefit in it breaking very obviously, so by refusing to load the program, because then we can spit out an error message saying the reason Xdp is not working is because you haven't enabled multibuff. Here's how to do that. Whereas if it just starts passing packets wrong, that can be really frustrating for people to figure out.
Right.
Actually, if I can give my 2 cents here, let's say, my opinion is that, as Alex said, nowadays it's not possible to load an Xdp program, to load an eBPF program when the MTU is over, let's say, 1 page or whatever. So the issue can only occur if, let's say, the system administrator increase the MTU over, let's say, it does not occur at boot time with the current situation. Just occur if the system administrator load an XDP program that is not multi-buffer aware and explicitly increase the MTU. Otherwise, it does not occur at the moment. So I'm not sure, let's say, this is super problematic, let's say, because it does not occur, let's say, without any intervention, from my point of view. But it is, for sure, it is something that we need to take into account, because it can break stuff.
So I think in practice, what would happen with the global switch is that it would just be enabled by default. And then what you would get is Xdp programs refusing to load unless you tell them to like -- force multi-buff or something, right? And the question then is, are people just going to do that and not worry about it and get bugs anyway? Like, so John is also in the chat suggesting a read-only field, where the so basically a way for user space to detect that multi-buff is supported by the kernel, if I understand you correctly, right, John? And then we could still have a way to make it obvious from an error point of view. So David Ahan is asking about so the problem with a Netdev attribute or per driver, with a Netdev attribute is redirects. Yeah, so David is also saying if an XDP program is going to redirect a multi-buffer, then you can check all netdevs that could be redirect targets for support. Yeah, so I think XDP programs that are aware of multi-buff are fine anyway. Like they can detect it and they can react accordingly. So the problem, as I see it, is someone running an existing, say, daemon that counts how many bytes goes through the interface, as a simple example. Then they upgrade the kernel underneath it, and suddenly it changes, and they haven't noticed, and the Xdp programs are not aware of this. And then they will just get wrong values, but everything will appear to work, and they're not aware of it in any way. And to me, the main question is, should we care about that?
Well, would that be an actual situation you'd run into, though? Because something like that, you'd then have to be explicitly, in most cases, you don't get into this mode until you change the MTU on the device to something larger than 4K. And so if, assuming that we don't encounter multi-buff until such time as you go and change the MTU, it would require 2 interventions then to actually trigger this code change and increasing the MTU.
Yes, that's true, but
we also discussed that with, like, I see it as not too dangerous because exactly you need to change the MCU also, but we are still leaving some corner cases, and maybe that's okay.
Yeah. So the question is, do we think it's a problem that maybe people are not aware that the MCU has anything to do with XDP, and suddenly they will go, oh, I want more performance, let's enable these jumbo frame things, and they may be running an XDP program that does that.
I think Salil proposed an interesting idea in the chat. He writes, why not to, like, if we are redirecting the multi-buffer Xdp MB to the driver or NICU which doesn't currently support it, why not just, like, to, let's say, allocate a compound page and just copy? I mean, yeah, it's a performance hit, but at least it won't, like, break something at some point.
Yeah, so like linearizing the whole thing, but can we do that if it's larger than page size?
Yeah, does it support compound pages?
But anyway, the issue will even occur, let's say, if I understood what you mean, even, let's say, without redirecting, right? I mean, theoretically, the issue is there even when you receive, you upgrade your kernel, and the system administrator increase the MTU over 4K, and is still running a not MB aware program. So it's just not, let's say, okay, even in this case, we can decide to linearize the packet. I don't know if it's the word to do it or not. Not sure.
I don't think on the receive, then we basically, it would be difficult to detect this situation, and then also all of a sudden people will get very strange behavior from on the receive side, having to allocate a new page, copy the whole thing over. It might make more sense on the redirect side that we have to send it out a specific device that doesn't support this way we chopped up the packet. But I'm not quite convinced we should do it. Maybe I would rather drop it, because people, they don't realize this, and then they start reporting performance issues.
We already have, like, drop packet if it doesn't work as the failure mode, right? For redirect.
Yes, and we have seen it multiple times with generic XDP. People think that they are running native XDP, but they're not. And then they run some tests, and then they get upset about the performance. And then we have to tell them that's because you're running generic XDP. So I don't like introducing these fallback modes that people don't notice.
Yeah. So it seems like people are leaning towards do nothing and other than expose the feature bit, and then let XDP program writers worry about it.
It could be not like a Netdev feature, but a Netdev private flag, because, flags are not, like, toggleable on and off, and if if the driver supports it, then it supports it all the time, right? We don't need to like enable or disable multi-buffer configuration to the ATH tool.
Yeah, but we want to expose Xdp features anyway, which is a separate topic.
Yeah,
I think
that's a
it's on the
separate
agenda
topic.
for this as well, right?
Well, that was something I was mentioning before. I was wondering if this would be something that would be better suited to like maybe add as extra metadata in Xdp mem type or something along those lines, or mem info. Since essentially it's just another form of memory arrangements, just we're doing scatter gather instead of just providing a linear page.
I don't want to place it in the mem info part because for most of the cases, it won't be a multi-buffer frame. It will only be a single buffer frame, right?
Well, right, but we're still having to initialize it like it's a multi-buffer, essentially. Most of the drivers will be, most likely, because they're going to initialize it, the NR frags to 0, and
that's what we are trying to avoid by having a single bit that says, is this a multi-buffer frame or not? And we set that single bit, and that if that bit is not set, we don't need to touch the other area at all.
Yes, actually, this is the exact reason why we introduced this multi-buffer bit at the end, because if we go along this road, I mean, always initialize the Xdp shared info data structure, we will probably have at least a cache miss for each frames, because this Xdp shared info will not be part, or will be not in the cache probably. So this is we are going this way. We are going to hit even the let's call the legacy use case where we have just a single buffer, and this is why I would like to put this information inside the Xdp frame instead of, inside the Xdp frame or Xdp buffer instead of memory.
Yeah, that's why we want to have it per frame in the Xdp buff as a single bit.
And moreover, it's not part of this topic, but we will probably use this field even for another topic of the discussion. This Xdp hardware hint will use this flag, some bits of the flag field in order to provide some, let's say, information that will be fast, that we need to access fast in the Xdp frame. So we have even this, using this approach, we have even this upside, I guess.
Yeah, we might use the flag for other things too.
Yes.
That's true, but we cannot make the argument before we post the patches.
Admins, can you please invite Salil and maybe John Fasterband on the stage, because they have raised hands, and I dropped a private message, but don't see the feedback.
So I don't see those raised hands. Who's raised hands? There's nothing in the raised hands. Raise your hand.
Yeah.
Okay.
All
right.
John, can you raise?
All right.
Great if John Fasterband
could raise
that. And John.
All right. The only thing is this silly platform only allows me to have only one person with a mic, and so I can only add them as speakers. I'll add John as a speaker then.
Yeah, that's fine.
Okay. So Salil is already on there, but I can't add a second person.
Right. So can I go ahead?
Yeah, sure.
Sure. Yeah. Thanks a lot for inviting, and hi to all. Most of the things you have discussed over there, just wanted to add up, isn't this akin to if you've got a router and you've got two different interfaces across which you want to route a packet, right? And administrator can actually wrongly configure outgoing egress interface with different MTUs or different attributes, right? In that case, basically, definitely you'll expect something wrong happening to the packet flow, right?
We already have MTU checks in place on egress.
Right. So my suggestion would be like, instead of just bluntly dropping the packets, can we have a warning posted out inside the kernel that once you detect this condition, which you're already doing it right now, that, okay, something is wrong with your configuration at the ingress and where the packet is coming from. And so you might expect a performance hit or something at the initial, and maybe in a case where we cannot accommodate a packet, say, for example, perhaps even in this case, there could be a case where you eventually would not be able to, say, allocate a buffer that much size, which will have a cumulative size of, if you add the sizes of all of the fragments, whatever are coming as part of the multi-buff. So in that case, definitely you'll have to drop the packet. But maybe why not do something a best effort scenario where first give a kind of a performance hit and still be able to forward the packet, and then have a stepwise approach of then ultimately dropping the packet. So the things will still continue till the time it says, no, I give up, I cannot forward it anymore for any set of packets, combination of packets. But till then,
the problem with this is it requires checks in the fast path, right? And we're already counting single if statements in that path and pruning them. So if we have to do sort of a multi-step for every packet when redirecting them, that's going to be a performance hit even when not using this feature.
Yeah, this check should already be there, right? Because you have to detect this even using your MB bit, MB aware with what you were just trying to suggest.
Yeah, but yes. There's two different things. Like, one thing is, does the driver support it? That we definitely need to detect. Like, when redirecting to a driver and that driver doesn't support multibuff, it's going to drop the packet. I don't think there's much we can do about that unless we want to add a whole new mode. The problem with backwards compatibility is, what if the Xdp program itself doesn't support multibuff? And that is not, today that would not be obvious. So should we add a new bit when you load an Hdp program that says, I am multibuff aware? Or should we just not care and people have to find that out of band?
Right.
The redirects side of the story is of course slightly different. So you want to have also a warning. We don't like warning messages because it will slow down the entire kernel, right, in the kernel log. So what I think for this case, we already have trace points you can enable to actually debug this. And later, I'm arguing that we need to add ETH tool error counters for the different types of redirects, so we can see that there are errors. So it's easier for the system administrator to figure out that this driver is dropping packets on redirect, which is one of the later topics. I think we should maybe cover it there.
I'm just trying to see this approach like, for example, if you see this as normal forwarding, whether the forwarding is happening between the interfaces or it's happening between the net stack, if you say, to any of the egress interface, right? So generally, if you take any transmit side, so when the packet enters the driver through the XMET, in that case, in fact, most of the drivers do that check whether they need to linearize the packet before they transmit or not, depending on the capability of the egress interface, right? So that kind of thing is already happening. I do understand your concern in this case, like what you all suggested. Maybe there could be some extra checks added, but till the time we actually calibrate what is the performance impact of such a check, vis-a-vis the kind of approach we can have, a flexible approach in which rather than immediately bluntly dropping the packet, we can have kind of still some sort of a thing going on till the time basically a person realizes that, okay, there's something wrong he did, and then he can take the corrective actions if it's a problem with the configuration mistake, or if it's a wrong card where the packets are being redirected.
The regular stack has a lot of checks and a lot of compatibility modes, and that's why Xdp is faster, right? Like, we can't really replicate all of the flexibility of the regular networking stack, because then we've just re-implemented the regular network stack. So why would people use XDP? So we're going like that's sort of the main trade-off with XDP as a data path, is that we sacrifice all the nice auto-config and flexibility for raw performance, and that means it gets harder to use. And of course, like it's a trade-off. So I'm not saying we can't change that, but we cannot make it as flexible as the regular stack. Right?
Yeah, perhaps maybe. Just a suggestion. I just thought maybe could be something we can discover out of it.
So, moreover, if we need to, let's say, modify driver by driver, each driver to support this linearization, maybe it's just a matter to implement the multi-buffer support for the redirect use case.
Yeah, I think this would definitely be something we could add later if it really turns out to be necessary in that case, right?
No, yes, but what I mean is that if we need to add, I mean, a point is if it's just supported, let's say, out of the box. But if we need to add some code, maybe it's just the better is to just implement the proper solution.
Yeah, my opinion is that we should implement this multi-buff redirect egress part, like the NDO, XMIT buff, the enter drivers, for every driver that we have in the tree. We should implement that they support this multi-buff format, because it's not, we know that every driver will work with this, right? Because we know we chose the same layout with the SKP shared info as the SKPs are using. So we can look at how the existing driver did the work of pulling out these fragments and sending it to the wire. So I'm pretty sure that all the drivers we can convert fairly easily. And then it's just a new requirement that you have to implement this as part of the NDO implementation.
Yeah.
Yes, we got John on as a speaker now, but it says he has low signal.
Sure. All I was going to say, or all I was saying in the chat was, I think from the patch series side, if we can fix year 1 and 3 the list there, the understanding the full length of the packet, and then also understanding the reading and writing the data. I think those are the two blocking issues. I'm actually okay with doing nothing for the user sort of the backward compatibility, even though I think I might have raised that concern originally. But I don't see an easy way around it, so I'm okay with doing nothing. Being able to know if a driver supports it or not is super useful for an agent. We can, kind of, we have an agent on the host, we can figure out what's going on and, convert all of our XDP programs. The only corner case is if somebody has XDP programs that are sort of not maintained, and they're users that don't understand really what, don't have deep knowledge of XDP. But if they're running a big network and using XDP and don't have an agent that understands this and don't have a maintained XDP stack, it would be nice to help them. But I'm sorry at some level, right?
So,
but anyways,
one question to that. So say you have this agent that understands this. How is the agent going to check that the XDP programs it is loading actually support XDP multi-buff?
So what I will do for the XDP programs that I maintain is make sure they understand multi-buff, right? Like that's the easiest thing to do.
Yeah, so
for some reason you can't do that,
only upgrade the kernel once you're sure you've checked all the XDP programs, basically.
So, right, I'll just say I don't support kernel 5.14 until I have XDP support with MB support, right? And I'll just say that's not supported. And that's easy to write into a SLA, right? Sorry.
Yeah.
I don't support your kernel. Deal with it. That happens all the time, right? I don't support, 4.9 in some cases. So fine. I'm okay with that actually. It's sort of a nice to have to be able to read it. I guess in that case, if you for some reason really didn't want to support MB at the XDP layer, you could then throw a big ugly warning and say I'm not going to load. But I don't think the kernel really needs to go bend over backwards to solve it, right? I view it as a nice to have. As long as we don't crash or do something horrible, then I'm if users do things that are kind of backwards and not working correctly, then oh well. I think XDP can do all kinds of things that'll break your network. So you really should understand what you're doing with XDP and real networks, right? Sample programs are one thing, right? But on the flip side, we have like real customers asking for this, so we don't want to hold this up on sort of theoretical. At least I don't want to hold this up on some theoretical debate on whether or not we can build some sort of foolproof ecosystem around this, right? So from my point of view, to get things going, let's just fix the issue that I actually have, which are 1 and 3, where I don't know the length and I can't read the data. Because I have programs that do that today, right? And there's just no way for them to work without those fields.
Right. So shall we move on to subtopic number 3, how to access payload data?
Yeah, and that's sort of a blocker, right? Also, why John is here. You say you have use cases where you want to dump all the payload, right? And maybe for that case, don't we today have a helper to get all the data out?
Yeah. So that case was fixed. That case was solved in the last patch series, so I'm okay with that. But we sometimes read the trailer on packets. In which case, and we also sometimes read into the payload, which, if you do multi-buffer, my concern is that some NIC will do header split and not give me the payload and put the payload in some pages after the first page. I can review every driver and make sure that doesn't happen. But ideally, in some rare case where this does happen, or some case where I need payload that's farther than 4K or farther than 2K or wherever the page size is, which can happen with like certificates, for example. So sometimes certificates are quite large. And I want to read into a certificate, for example. For those use cases, I really do need to read the data. It's not just about pushing it all to user space. It's like I actually want to be able to read and write into the data into the packet. And so for those, I really need to have like a helper. Now, I don't think it needs to be fully transparent. Like my ideal, like if I was just making stuff up and had a perfect world, I would be able to just say, byte offset plus whatever, 4K plus 2, read the data, and the verifier would somehow magically understand that was inbounds and needs to jump over a frag and would rewrite all the headers for me. Like that's, I think, a whole bunch of work and minimally valuable, right, for this kind of case where sometimes this happens. So what I think is probably the most kind of practical solution that gets us going forward so that we're not just stuck here forever, is to just have a very simple helper that says, I want to move the data head to frag 1 or byte 4K, and then the helper can just move data and data head, data meta, and data end, and then it will it can just reset the verifier so that the verifier knows that all pointers need to be rechecked. We already have the fields for other things. So that to me looks like pretty minimal amount of work and could be doable. And I think I proposed it on the list, and I think I even said I would try to hack it up, and I haven't got to it yet. But I mean,
yeah. So this would be like when tail adjust will like the verifier will then mark all check. Like you have to redo all the checks for data and data end after calling that helper, right? So you would do the same thing for this.
Same thing.
Yeah.
Yep. Exactly.
Yes, and I think,
and in that way, I think you don't actually have to do any verifier work per se. I think you just need the helper and set this bit. Maybe it needs to be added to the list in the verifier of things that reset pointers, but like the verifier, the intrusion on the verifier is going to be super small. Like it's not a heavy lift by any means. It's just a matter of getting the helper in place.
So, and the nice thing about this is like it's a bit of a cumbersome API, right? But we can always add a better one on top if we come up with one.
Which is exactly what we did at the TC layer, right? So initially you had to use all these sort of ugly helpers, and then we got direct write. So if at some point this becomes really, so from my perspective, this is like an escape hatch, right? I need to be able to make sure my programs keep working even under these kind of scenarios that are sort of not the 90% case, right? 90% is going to be normal. Things are going to be working fine. There's this maybe 10% or less case where I might need to jump to the trailer to read the trailer bytes. So like, I need some way to do it to keep the programs working, but it's not fast path. And even if it is fast path, I don't mind doing a helper. And if it becomes a problem for me and my benchmarks and people complain, then I don't think that folks doing this work who don't have that use case should be required to sort of fix that problem in best case. They just need some way for me to do it, right?
Yeah.
That sort of makes sense.
Even Elko has patches that actually implemented this, right? I was mentioning that.
Yeah, I also remember Elko having patches, just doing this, just moving the frag number.
Yeah, and I have a slide here from 2018 conference that also had a proposal of like scatter and gather buffers for eBPF and Xdp, and yeah, there was the same proposals against how to provide access to the different fragments. And here's the like example.
So the only feedback I'll have here is that doing it by SG is a bit awkward for the program. Yes, it might work, but it would be better if you could do it by byte, because generally what I'm trying to do is I've read like a TLV at the header that has a length field, and I'm walking TLVs is usually what's happening here. And so usually you can walk TLVs in the payload, and you might end up, if like it's a certificate or something, like a 501x or whatever they are, certificate, those things can be quite large. And if you have a list of them, each one is a TLV, you might end up, 4K down the line if it's a jumbo frame, which is kind of wild. Like that's sort of not a very friendly packet to the network, but it's, occasionally they do happen.
Yeah. So the helper, you would pass it I want access to byte 4002, and then it would move data and data end to what, to 4002 or to the fragment that encompasses that? Like, would you get a partial
I'm actually okay with either. Whatever makes the most sense when you program it, I think. Like, if you'd return the frag, you need to tell me the byte offset of the start of the frag as maybe the return value, so that I know where in the packet the program is, right? So that would be one way. Just return the frag for data head, data end, and then return just as an int the positive offset into the overall packet, so that I have some frame of reference, right? Because I need to know where that frag is starting. So that would be a perfectly fine API, I think. You could also return maybe to the start, but then I guess if I ever had to go backwards, it would be a little awkward. But I think either would be fine. I don't particularly care.
All right, that sounds reasonable to me.
Yeah.
We have two interesting messages. Tom Herbert says that we call 4K of TLVs a denial of service attack. And there's a question from Ivan. He says that many applications still don't have a need for multi-buffer configurations, like the programs that need only to access the headers, for example, like L3 or L4 headers or whatever. So why just don't implement the multi-buffer and leave it disabled by default, but allow to enable it via H2, if needed?
Yeah, I think you sort of enable it when you increase the MTU. And if you only are interested in the first part of the package, you just keep passing that, and then you redirect it. But if it happens to be a multi-buff packet, you should get basically the same performance. It should not slow you down. You can just redirect a multi-buff packet, and you really don't know. You just looked at the headers, and it will still redirect it out another interface, and it will just work.
Right. So to summarize, maybe did we land on, as a stopgap for the payload data, we will some kind of helper that moves data and data end will be at least what we start with. And then if someone comes up with a better API and wants to implement it, then we can add that on top later so that we're not blocked on this issue. And as for backwards compatibility, we'll basically do nothing and let the user deal with any breakage that might occur. And then on total packet length, that's also a helper, or did we not? That we didn't cover yet, right?
I want to hear opinions about if this should be a helper, because if you added the packet length as a helper, you automatically get that you cannot load the program unless the helper exists, right? And then your kernel supports multibuff.
But only if you care about the length.
Yeah, only if you care about length, that's true.
So I guess if we don't add a helper to get the total packet length, the only way to discover it would be by walking the packet fragment by fragment. If you know that it's a multibuff, right? With this helper that moves data length, then you will just try to do data end +1, see if that works, and if it does, you will add the length of the next fragment and repeat, just to get the length.
I think we need something easier to get the length.
Yeah, that was where I was going with this. But just having a helper that just returns the length. Done.
I think that would be super easy, but I want to hear maybe John's input because he's more insight than me.
I don't know. We sometimes keep statistics about bytes going through the network. So if every packet has to walk all, if we have to walk all the frags in a network that has a 9K MTU on every packet just to get the length, that's not going to be acceptable, really, from a performance standpoint. So you need to have some way to get it. I don't know if it's I would just stick it in the metadata, maybe. Just we have a spot for it, right? We can just put it there. Total length.
When you say metadata, is it in the context?
Like in between the XDP metadata and the XDP data head, right? You can just write it into that space, right?
Then that will depend on XDP and the Xdp Hints work to actually.
Exactly.
Yeah.
Giving you a good segue, but I think it makes a lot of.
I don't think it's super optimal to do that, because as soon as you write into the metadata, there's a risk of having another cache miss, right? As soon as we talk about Xdp Hints, we also have to consider that we are touching another cache line. And that's really something people should be able to opt out of.
It should be in cache, right? Because of DDIO and everything.
No, it's going to be the section before the start of the data is the problem.
Okay, fair enough.
So it's right on the cache line boundary. So it's actually a tricky point from a performance point of view, the Xdp Hints.
But then it could be like we could make the packet hint just another Xdp hint that you opt into configuring by whichever mechanism you configure all the other Xdp hints. But then you would take the performance hit if you want the length.
Well, I think what you're going to end up with is you're going to have to do two different things. You're going to end up having to do this bit check for the flag to say, is this legacy or is this a multi-buff? And if it's multi-buff, you're going to probably have to have this total length stored somewhere in the shared info block anyway. And so the shared info block ends up being the place where we probably have to have it stored. And so you're going to end up with a conditional setup, or if not multi-buff, it's data start versus data end, else add, or do that, and then if it's multi-buff, you add the frags length.
Yeah. Okay, so but with a helper, the helper could do that or that, and then that could just continue working on existing packets, right, and just return data.
But helpers are not free either. They're calls, right? I don't know. Maybe ignore it for the first pass. I'm just trying. I mean,
I think we tried to do that, but then someone, I think he was named John, wanted it to help her, or some way to get it.
I might have complained. I might have complained, but customers are getting grumpy that their MTUs don't work either. So the pressure to get something done is mounting.
All right. So ignoring it implies have the program walk all the frags if they want the length, right? For now.
Likely, what I'll do is I'll pull it out of the header. I won't actually walk all the frags.
Okay.
With TCP packets, I'll just grab the length. I'll grab it out of the headers instead of out of the data.
Oh, so people can smuggle data at the end of the work.
Yeah, I mean, if your network's hostile, for sure.
Yeah, good thing those don't exist. All right.
I don't know. I don't have a good answer. I have to think. Some to think about it.
But like if we can always add the helper later as well, right? As long as we agree that it's not a blocking issue, we could proceed without it, and then if it does turn out to be really important to have the length, we can just add a helper or an Xdp hint if we're done with that by that time.
Yeah.
And with the helper, we could also
something like this,
choose not to use the helper.
Yeah, but the helper is not. Helpers are kind of slow. They're not really great options. It's much better to have have the verifier rewrite it as a read or a load instead of a full call. But we could always do a helper rewrite if the hints were available.
Yeah.
Like if you could have a helper for everyone that doesn't have the hint, and then if the hint's there in the core, we could have a rewrite of the helper. We do this for arrays already. Like if you have an array lookup, for example, we'll actually the verifier will rewrite this as a load instead of a call.
I was also thinking thinking those in that direction. We could optimize that in this way. And
I would probably push for not including it in the first one if we can get away with it.
I'll have to see how much other folks here will scream.
Yeah.
I have to see how much that will break.
Yeah.
Without it. Let's see.
Yeah. I kind of would have liked to have a length helper to start with, because then we wouldn't have the backward compatibility issue, right? We could just have extended the length helper. But that's...
So what's the reason we can't put it in the context object again? We out of bits?
There's room in the context object, I think. In the XDP buff or XDP_MD.
Well, maybe put it there. I don't have a problem with it, I don't think.
There's a field called frame size for to tell the program the boundary for to which the program could grow the packet. But what if we could use this field for multi-buffer to tell the full length of the packet?
We need the frame size. We need that to find the SKB shared info area.
Yes.
So you cannot reuse that because that's tying everything else together. But we could just. I think there is room in there to add a field with the length.
But XDP program don't need an access to shared info, right? So we could set frame size and then BPF core, whatever helper that will create shared info, we'll use our frame size and then replace the field with the like total packet length or whatever.
So from the BPF API point of view, if we define it as a member of struct xdpmd, then the verifier is going to rewrite those loads in arbitrary ways anyway, right?
At least to my understanding, yes.
Yeah.
Maybe we should move on to the Xdp Hints topic. We have already spent an hour on the, on the first one.
Yeah, we have less than 1 hour.
I think the code overall, though.
Yeah, okay.
I think overall that it's very close. So like, keep at it, because maybe I've been fairly critical on the list, but I think it's actually getting really close. So let's keep it going. I think we'll get it here in the next. Hopefully in BPF this next kind of round. So I'm optimistic overall.
Great.
I think we're all. Okay, so the next one is Hdp Hints, and first of all, I want Michal to be on the stage, so please raise your hand if you're here. Okay, fine. So while he is going up to the stage, for those who aren't aware of what Xdp Hints is kind of the way to provide the like info like timestamps, VLANs, checksum, RSS hashes and stuff to the Xdp program on Rx path, and then the way to tell the NIC, the driver, what kind of offloads, like for example, calculate the checksum please, or calculate whatever, or do the timestamp, to tell this from the Xdp program to the driver. So for each one we use like metadata, and there was like a mini topic about the cache line misses and the metadata, and I think that most of the drivers for now, instead of prefetching the Xdp data pointer, now tend to prefetch the Xdp data meta pointer, because if there is no metadata, then it just points to the actual data, and where it is, it's fine. So yeah, and we published like not an RFC, like work in progress and raw stuff, some like day ago, and our first approach was to like to create a ladder of if and else's in the driver code, and yeah, that was obviously rejected because we have like a core stuff that allows us to have like different NICs with different like descriptor layout, and then when we load Xdp program, then libbpf core will rewrite the offsets. But the thing is that this core thing works only with Xdp programs, which is obviously is a BPF object code, and not with the AF Xdp programs, which is like x86 or ARM64 or whatever. So it obviously doesn't work, and Alexei even like proposed us to patch LLVM to allow it to rewrite like object code, and then convince LLVM maintainers to like accept our things. But yeah, so here we are, and
yeah, I proposed a much simpler solution. Like in your user space program, you just figure out the offset, and you keep in your C code, you keep track of the offset, and you know the size, and then you simply typecast your way into the data. And it's of course, the LLVM compiler can do this for you, but it's not that complicated. It doesn't cost that much more in user space to just keep track of offset into the data area and then typecasting it.
Yeah, but if we load the program to a different driver, different NIC, which has, for example, different metadata layout.
Yeah, that's why I want the metadata or the BTF ID. So you have that, and then you key on that, and then look up in your data structure which offset it is. And performance-wise, you would then do the lookup, and then assume that this driver will most likely return the same BTF ID, and then you will keep a pointer to that. And if it doesn't match, you have to look up a new BTF ID. But in most situations, it will be the same. So you don't have to do the lookup. So I don't think it's that complicated.
Yeah, I also think that we should first of all provide some kind of generic structure, generic metadata, which will contain very common fields like RSS hash and checksums and VLANs if it was stripped, and timestamps. So almost every NIC could provide it. So we don't need like 100 different layouts for these fields. And these fields aren't that aren't that large. And if your program needs some custom fields, then you get a performance hit, but it's your choice, right?
Yeah. So does anybody else want to bring something up in this area? Because
there are questions on the chat, if someone can monitor that.
I was not monitoring that. Yeah, Tom asked how many metadata items do we expect? Now I jumped. How many do we expect a device to provide in a single packet? I'm not quite sure I follow it, but it will create
how many different fields will be enabled at the same time? Will we have hash? Will we have checksum? Like how many? I think that's what he means. Correct.
Yeah, like Alexander says, we will probably in most cases have a standard one that a NIC provides those, but then you once you enable, for example, the timestamping stuff, which I'm very interested in, that will then change the layout or extend it, right? So you add one more, but it is kind of a sort of a good question that I see this as an extremely flexible way of expressing everything, right? That's what we want. We want very flexible there, but at the same time, the driver side is very inflexible. And for the first iterations of this, it will still be kind of not non-flexible. It will export some pretty simple and standard fields, but we want the flexibility in there so we can start inventing new kinds of fields we want to export, right?
Yeah,
I think this is what the NIC driver always wanted, right? You can go to a NIC feature and you can expose it and never have to deal with the kind of kernel community, I think.
Yeah, exactly. It's sort of what the vendors always wanted, right? So I think it has a huge potential.
Yeah, because even, for example, the CPU map, when we just redirecting packets from one NIC to from one core or from one CPU to the other, we obviously lose the checksum, the RSS hash, and it's all being processed by the CPU for the second time, and it's just slow down the whole thing.
Yeah, that's especially with the CPU map and also redirect into a VHH. It is actually that actually means I want to consume. I think that's one part that I'm not sure that John followed on the list, that I actually want to consume it from the kernel itself, these metadata. So I actually want kernel code to decode this and understand there's a receive hash, there's the checksum. And then I want to, when I convert from an Xdp frame into an Xdp, into a normal SKB, then I want this information also. It will be kind of fixed what I have to support. So this is why I think it's not a problem. I will have to support the things that the SKB supports. So I don't need to be super flexible there, but I need to be able to decode the different drivers layout of this area.
Yeah, sorry to interject, but there's a bunch of people queued at the mic. Either Alexander, maybe keep track of that, or I can. How do you like me to do it? I can just let them in, and then you.
Yeah, just let them in.
All right. So here comes Tom.
Okay, can you hear me?
Yeah. Hi.
Okay, so I guess there was a little more background to my question. How many data items would be coming in a packet? So if you say this is 1 or 2 or 3, then why not just copy the data into a common metadata buffer and format it in the driver? If you say it's 10 or 20, then that raises the other interesting question, which I think, let me get this right. I think Salil alluded to. If we want to be able to completely customize this and go way beyond, say, simple checksum and maybe a couple hashes, what if we want the IP addresses, or we want offsets to packets, or we want? So the thing is, we know that modern NICs have incredible parsing capabilities, so they conceptually can extract a whole bunch of information that may be useful to the host, XDP or whatever. But the fundamental problem we have is conveying that information that they extract to the host is the problem. So right now, for instance, we obviously want most implementations would be using the receive descriptor. Receive descriptors are like 64 bytes at best. Some may be a little bigger. But that's so limited, the amount of information we could convey in that it quickly becomes obvious that you'd want to go beyond that. So for the simple cases, a couple checksums, maybe hash value or other, you could probably fit a couple of those into the receive descriptor. But if you want to go beyond that, if you really want to take full advantage of the capabilities of the NICs to parse and find out information of a packet, it's really going to have to be a different model, because even if you try to prepend this data, say, to the packet and send it over the PCIe bus, and you're not consuming PCIe bandwidth, which is really expensive. So for instance, if somebody's doing something really dumb, like extracting IPv6 addresses out of a packet and then puts those into metadata that's shipped across the PCIe bus, you're now sending 32 bytes of metadata overhead when your packet might not even be 64 bytes. So this is where I think these kind of fundamental problems with Xdp Hints start to show themselves. So like I said, I think the operative question I have right now is, what is the scope of the problem? If the intent is just to have a few data values, and I think Jesper said make it standard, then that's one thing. But if we're looking that this is going to be a really general purpose function, where we're going to be able to program precisely in the device the information that we want to extract it, the device is going to be able to put this into a data format that is very consumable by the host, that's a different thing. And I would point out there is one mitigation to the PCIe bus problem that's coming, that's CXL. We will have the ability to read the sort of metadata from the NIC address space at some point with CXL. So that's one mitigating factor.
So I think from my point of view, it's this means to be flexible, but not to solve the space problem, right? So the idea is you have this metadata space which is only 32 or 64 bytes before the packet that you can use, and if the driver wants to fill that out completely with this BTF described metadata format, it can do so. And then the benefit of having BTF as describing it is that, say you're space constrained and say, I want the IP addresses, so I'll just get rid of the checksum because I don't need that for my application. So that you can completely flexibly rearrange this limited space in the way that you want and use BTF to communicate what does it actually contain.
Right, but as good as BTF is, the alternative would just be run a little function in the driver that says my device descriptor is this format, and just copy out the data into the stack format. Because the other thing is, thinking about BTF, it seems like this ties the implementation to that particular driver. And we get away with this in XDP because it's localized. But imagine if we want to convey this information further upstream. If we want to inject this information into the stack, then we can't do BTF because the stack itself obviously has to handle every possible driver. So there's no way it will have to customize. So you have to do that copy anyway. So we need to copy checksum from received device descriptor. We need to copy checksum complete into the SK buff. There's no way around that, right? So I think we may be a little myopic in terms of solving a limited problem right now.
So that's why we propose to have a generic one structure that is generic to all NICs, and the others are more customized and stuff. So the kernel itself, for example, when receiving XDP frames from the CPU map, don't need to assume that, not assume, but don't have to guess which DPF type it is or stuff. So it just needs to be in one format for all NICs. And when you need some kind of additional information, like something from the headers or stuff, flow ID, well, maybe flow ID is more kind of generic, but some kind of more customized stuff, then just use separate BDF ID, and it will, because if for example some Intel's NICs have a descriptor of more than 100 bytes and more than 150 bytes, and if we, for example, need only a checksum which is 32 bits sized, we don't need to copy the entire descriptor. It will be an overkill. So that's why we want to keep a generic struct really tight and carry only the very much needed fields, for example, for VETH and CPU map and stuff, and the same for TX. And also, I think that
we could give you access to the descriptors, but so
I don't think it is safe to give the access to.
And I think to one thing I think I got from what you said, Tom, is I don't think the proposal now is to make BPF programs read directly from the descriptor. That's not what we're using BTF for. Rather, the idea is that the driver takes its descriptor, looks at its configuration and say, I have these two metadata fields enabled by Tool or whatever. I will copy these two fields into the Xdp metadata area in front of the packet in this format. And then I will use BTF to describe what format is the data that is in that metadata field. It's not describing the descriptor directly. So the data will be copied anyway.
So we're copying the data anyway.
Yeah. And we just solve this
yeah.
without BTF by just having one struct that has all the data, like the common fields from all drivers, right? But that would be less flexible in case we want to add some new stuff later.
Okay, so that would be good. So this is currently done. So BTF would be common across all drivers, and then we have compatibility.
So so the compatibility comes by drivers being able to say, this is the format that I am writing into my metadata field, and then the BPF program can say, I will look at the BTF ID, which is carried with the packet. Like we write the ID of the BTF into the packet, and it's carried with it when it's redirected, when it's going to user space, etc. So that the BPF program can look at this BTF ID and say, do I know what this is? Okay, then I will read the fields. Otherwise, I will ignore them.
Yeah, and in addition to Jesper's answer to why isn't that safe to give an access to Xdp programs to the descriptors, I don't think that given access to like DMA is like a good idea. I mean, to give an access to DMA from the users from a BPF program or the user space isn't good at all. Yeah.
I'm gonna just interject again. Sake of time, you're about 30 minutes. You have a lot of other agenda items. Can I let in the other people?
Yeah, sure.
Okay.
Thank you.
I can only allow one at a time, okay, on the mic.
Okay.
All right, here comes Salil.
Right, hi. I mean, most of the things what I asked have been discussed here. It was the same thing which I wanted to ask. I mean, why not make it generic so that we don't have to depend upon the descriptor like we do right now, which is like we generally have a very limited number of fields which come as what we call as hints, or it can be the RX6M, or it could be anything. What the NIC is being sending. My idea was like, why not have some sort of a generic field, which I think you guys have already answered, and then which can be programmed through some interface like a tool, and you can put any value which could act as a color, and that could be used either by the Xdp program itself, or that can be sent to the stack. The idea was to have something like a per flow dropping case in which you know what exactly, there's a bunch of flows coming from the same source, but you only want to drop certain kind of flows which match certain characteristics, right? So you need further classification of packets, and it would be good if those are pre-classified as part of the NIC itself, because that otherwise will take a lot of CPU. If we start doing the same thing as part of the
that is exactly what we want to enable, those kinds of use cases where the user says, I have this special NIC that for whatever reason can produce these completely new pieces of metadata, like a flow classifier. And that is what will be included in the Hdp metadata area. And this is the format that it will be in by way of a BTF ID. And then the BPF program can look at that BTF ID and say, oh, cool, it has this new metadata format. Let me pass that and use it to make a decision.
Sure, yeah.
And
Sure,
to
yes.
answer Jamal's question in the chat, like if the hardware can just stick the data onto the packet before the packet data, and the driver can just communicate that fact by the same mechanism, that would be totally fine.
Exactly, yeah.
Yeah, we discussed it also on the mailing list that the future NICs will be able to, you could program them to tell, hey, I want the checksum and the flow ID, for example, to prepend it before the actual packet buffer, and then we won't need to do manual copying in the driver itself, because NIC would do it for us. But it's more of a future NICs, and for a current, we should keep a balance between the flexibility and the performance, because as Toki said, we count every ifs for now.
Yeah, so the copying that the driver will do from RX descriptors into the metadata field is kind of a compatibility thing, right? Because this is how drivers work today, so they can just copy those data from its configuration. But that same mechanism of accessing data from the BPF program will also work in the future, where the hardware can just write it directly.
Right. Yeah.
Yeah, that is the core of the design. Eventually, we want to push those to hardware.
Yeah, and so and also having the BTF ID in there, which just says this is the data format. That also means that an AFXDP user space program can read that field and then pass the data as well.
Yeah, sure.
And I think someone asked earlier, is this possible to do, like the libbpf relocation stuff, use that from user space this way? I don't think that's possible today, but it would be possible to enable this either manually by like having a library that will pass the BTF and produce offsets that you can just look up from a table, or even having all the actual relocation support in LLVM work for user space code as well. The latter is obviously a bit harder.
Yeah, it was asked by Michal, who's currently working on the hints, and that's I think the one of like ideal ways to have the like library or whatever rewrites not only the XDP program but also AFXDP program and stuff for us. But yeah, it's also kind of a future because for now there's no such option.
Yeah. So.
Yeah. Okay, go ahead.
Jesper. Yeah, so I was just saying, I mean, like that might help the DPDK, the AF XDP PMD as well, which you can run as part of. So that might expedite that area as well. And that's it I wanted to add.
Yeah, that would be totally possible as well with this.
Yeah, and the VMware guys that has the OVS plugin that doesn't use DPDK also wants this. They have talked to us about the AFXDP wanting to consume the different, like the receive hash. So there's definitely users that wants this.
Sure. There's a lot.
Yeah. So and like a lot of the tooling and how to access all this data via the BTF and making this really convenient is really sort of a tooling problem that we can solve afterwards. The important thing to agree on when defining it is sort of the binary format that we put on the wire, so to speak. Like what do we put into the HTTP metadata field? And so the benefit of having sort of the trick that I think it was Björn that came up with, right? If we just write the BTF ID as the last 4 bytes of the metadata, you always know where that is, and then you can you read the flag says this has metadata. You read the BTF ID, and from that BTF ID you can query the kernel, which you would also do ahead of time, which will tell you it will tell you both the size and the contents of that struct. And that means you can unambiguously tell what is this metadata that I'm reading and react to it. And then we can have all the magic in libbpf that will rewrite the BPF code to just do this automatically and make it really efficient and so on. But the main thing is really like having the binary format of the data that's there and agreeing on that.
Yeah. And you mentioned libbpf. I wanted to. I hopefully we can convince the libbpf maintainers that we can export some of the APIs, because they're already on the user space side. They are already doing the lookups and matching against and finding the BTF IDs, because you can actually from user space say I want this struct name, and it is actually on the completely on the user space side. The libbpf will figure out what the ID is for you before it loads this into the kernel. So it has nothing to do with the kernel. It happens 100% in libbpf that looks up as the kernel, of course, but finds the ID for you. So I'm hoping we can just leverage that code.
Yeah.
So, but as Togi said, there's a tooling issue that I think we can resolve.
Yeah, sure.
All right, shall we move on?
It looks
I
like
think so.
Alex,
Oh, we didn't use all the time with those two subjects. I was.
So the next topic is, which is really, really old, I guess, from the beginning of time of HTTP, is the feature prediction. Yeah, I think there was some Intel guy that worked on it, and I asked Toge to push the guy on the stomach. I don't know.
And he hasn't. So he sort of dropped out due to personal issues. So if someone wants to take this up, I think that would be possible. And there is a work in progress patch set. I think you're both, Jesper and I, are happy to work with anyone who wants to work on this. I don't think we should probably spend too much time discussing it right here. Just a sort of FYI, ping us or on the list if someone is interested in working on this, and we can get the ball rolling again.
Yeah.
All right, speak up now.
Yeah, I mean, like, in fact, we were doing something related to this. Maybe I'll get offline with respect to this topic to you guys.
Awesome.
That'd be great. So on to the next topic, because we are short on time. So I don't think we can discuss it in full length. This is Toge's topic about QoS and queuing. I think it's a huge area, but I think we want to make you aware that we have actually people working on this now.
Yeah, so this was just an FYI. I was we are targeting a presentation in LPC to actually present the details. So this is just a kind of a teaser, and get in touch if you want to know more ahead of that. But it's very early. But just very briefly, the problem is you cannot queue, reorder, or reorder packets in Hdp. In a sense, it works like a very shallow buffered switch. So if you have any kind of RAID transition, or if you want to do QoS or anything like that, you're out of luck now. So, and we want to fix this. And there's some interesting work in academia on programmable queuing for hardware switches, and there's a software realization. Those are the links in the blog text there that we're trying to adapt to XDP and figure out. Obviously, this is eBPF. We want programmable queuing, and we want it to be really lightweight and fast. So we can't just stick stuff into queue disks. And we have some ideas for how to do this. Basically, the idea is you redirect packets into a queue instead of to a device, and then we need some hook on the other side to pull them back out, and then some eBPF code in the middle to figure out the order and what to do with it. That's the very short version. So just a sort of FYI, we're working on this, and stay tuned for more.
Yeah, and we managed to hire a PhD student to do some of the work. So it could take a long time, because he's not finished before like 4-5 years.
Yeah, we're hoping to have something at least present before he actually graduates. But there's some follow-up work that is obviously in the research department.
So let's move on to the next topic, which is the issue of that we've had for some time now, that sort of involve all the NIC vendors that are listening in, that we have this problem of when, I think it's originated back to John Fasterben's original design, that to make it really fast, when we are redirecting, we just use the CPU SMP number to figure out what transmit queue to use, and we have a transmit queue per CPU. It's super fast, but there's also limitations on the hardware, how many transmit queues you can have. And all of a sudden, if you have a system with a lot of CPUs, then the hardware might not be able to provide enough transmit queues. And then what should we do? It turns out that there's always variations in the drivers, which is, I'm not going to list all of them, but I've listed them in the document of all the different situations we can drop and deny and report messages and even crash. That's been some of the funner versions of just simply crashing the entire system.
Just wanted to check with you guys, like while coding the driver for the HNS, I just came with an issue like somehow like our hardware didn't support exporting the queues in a way in which you have a separate RX queues and a TX queues. So we ended up in a kind of a situation in which we had to duplicate the number of TQPs, that is a queue pairs, together, which wasted something half of the RX queues which were being used for the the TX queues which were being used for the XDP purpose, like for the redirect path or the TX path. So I was just wondering, for the XDP TX path, we generally have one-to-one correspondence between the RX queues and the TX queues. And for the redirect path, generally this is something which is kind of vague because the redirection path can lead to a NIC to an altogether different vendor, and the configuration of that particular interface might be altogether different. So I don't know whether it would be considered as something like a issue which is related to a configuration, or it is something which could be something we can have a kind of a way to communicate what is the, or maybe kind of sync up between the ingress and the egress path, that you should be at the right kind of configuration to have a right kind of QoS, so that there are no packet drops or something. I don't know whether it makes sense to have such a thing, but
it's difficult to say how to solve it, really. I'm really open to inputs.
Yeah, by the way, if I'm correct, the work that is going on under this link is about to determine if we have enough queues for the number of CPUs, and if so, then we use the standard lockless XDP TX. And if we don't have such number of TX queues, XDP TX queues, then we start to use spin locks or stuff to be sure that all CPUs could transmit, but under the lock. And yeah, it's a slowdown, but at least it's not a crash, it's not a silent drop and stuff. I saw another solution that involved uses of the static keys that is obviously more faster than just plain ifs, but the downside of static keys is that they can't be embedded in the structures, so they are global. And when it comes to drivers, we might have, let's say, 5 NICs, and let's say we run out of queues on one NIC of 5, and the static key can be only global and not embedded in the structure. And this way we can determine we either will turn this spin lock system on all NICs, or I don't know. So yeah, that's a kind of issue.
Yeah,
because it's
for people to understand what's being proposed. I would like to explain what's actually. This is also my proposal, sort of that I want. If there's resource contamination or limitations, we will take a lot per 16 packets that is getting pushed down. But a thing to realize, we are taking a lot per 16 packets that amortize the lock. But the real cost of sending something is ringing the doorbell on the NIC, and that actually first happens at the end of the flush. So you could, even though you take a lock per 16 packet, then the doorbell is rang on the last 64 packet going down into the NIC if you use the whole NABI budget. Just so people understand the performance impact. I heard someone speaking up. My general input is that all driver vendors need to fix this, and this is sort of the drawback of XDP, right? We put the stuff into the driver, so we have to, all the driver vendors have to.
Just another heads up for time. You have about 15 minutes. There's always a lounge. There's tables. You can go and sit there and continue the discussion after. Up to 50 people can sit on that table.
Yeah. So can you scroll down to the next topic?
Yeah.
It is
Yeah.
Slightly related, because this is also all NIC vendors have to agree on how we count the packets, because we're doing this in the drivers. So the argument here is that we actually want to count the Xdp drops as received packets, because it's a policy choice that you're dropping them, and because other tools like SNMPD that will monitor will get confused if you're not counting all the packets received on the interface.
Jakob recently introduced a sort of like standard statistics for the ATH tool, so we could like add the same thing but for the like Xdp part, so all the drivers could fill the standard fields. But yeah, they should agree on how to count the packets, because it happens like differently on different NICs, even on different like versions of like revisions. So yeah,
that's a really good suggestion, because if you scroll down to the ETH tool stuff, then I've tried to describe some of the actions or some of the standard fields that you should use for the ETH tool. Some of them are kind of critical. So we have. I also want drivers to count some of the transmit errors, because they can be really hard to figure out until Toga implements a full queuing layer. We don't have any pushback mechanism, and you can easily have, if there's a 100 gig NIC coming in trying to transmit out of a 10 gig NIC, you will have overflows in different funny situations, and we need some error counters to account for that.
Well, wouldn't that count more as a TX drop though than just a rather generic TX error?
I listed it in the document. If I can get Alex to scroll down. Which one are you talking about?
Yeah, sure.
Well, like you're referring to the RX XTP TX errors and the transmit errors. You're talking about the situation where you have like a 100 gig port trying to send traffic to a slower port. And those would just technically just be drops, which we do have a category for drops already. So it would seem like that would be something that would be caught as like a transmit drop instead of just a transmit error.
No, it won't be caught as a transmit drop, actually, because it happens too late. So there's no feedback into the driver that is sending them, because we're having this bulking step. So we cannot report it back to the original program.
No, so I'm not saying report back to the regional program, but like in terms of the stats in the ETH tool, instead of just calling it a generic transmit error, it'd be a transmit drop. Just be a bit more specific on the specific type of error that is being seen. This standard response for TX is going to be to drop the packet. So instead of it just saying it's an error, like in XDP, I can't think of too many cases where you'd actually have any sort of error. It'll almost always be drops, at least, assuming that this is tracking stuff going to the hardware, not coming back from the hardware.
This is tracking like overflowing the queue on the
right.
hardware.
So those would just be drops then.
Yeah, so you want to rename it, instead of errors, call it drops.
Right.
That might be a good idea.
You already have the XDP drop, the standard drop case. This would be a secondary drop for overruns.
Yeah. Yeah, I didn't want to call it overruns because I think it catches two kind of situations. I can't remember which one. One of them is overrun. That's good input, but we should definitely start to standardize drivers on this. And Lorenzo have been working on this and fixed up a lot of the drivers he have listed here. I'm not sure the MLX5 driver has been fixed.
No, I think so. I think, if I remember correctly, because it has been done quite time ago. But I think the name were taken from the MLX5. I think. I mean the errors. Let's say Xmit error or Xmit. I can't remember can you scroll up a little bit, please?
Sure.
Has been taken from the MLX5. Yes. RX, XDP, TX error, and TX, XDP, XMIT errors has been taken from there, I guess. But for me, I'm fine to rename it in drops instead of errors. Just a matter of to be aligned on what we want.
Yeah, maybe we can take it offline because it's like a naming issue is the hardest problem in computer science. So.
Yeah.
Maybe can we scroll down to the topic connection tracking. I'm sure John has an opinion here about because Cilium has went a route of implementing this as a library. But I think Toga and I are on the opinion of we should have a connection tracking helper because it makes it possible to interact a little bit better with the stack. So any opinions?
I mean, my opinion, I think, is fairly opinionated, but I think Alexa gave you the feedback, right? So there's if we want to do it, then that's the way to do it. I think I don't see the need or really the desire to do it, but really why it's a use case. But I think on the list is the
so this would involve doing the
answer.
Unstable helpers approach and hooking into contract that way, which I think is the direction we're going.
And it's fine that you have a library for it. It would be actually great if make that library more accessible. But we have users and customers that want to have the connection tracking helper, right?
Yeah.
So sorry, I'm interjecting.
Sure.
I'm taking advantage of being rote here, so I can chime in without raising my hand. Okay, so understandable if someone wants connection tracking as specified by NetFilter. I don't think you need all those features.
Certainly not.
I definitely like what Cilium is doing. We actually the presentation that I'm going to present on sometime next week on what we did as P tables. We also bypassed NetFilter precisely for performance reasons. I will show some performance numbers as to why we decided to go our own path. So as long as the freedom is left not to depend on contracting, for example, then that's fine. I think everybody let 1,000 flowers bloom.
Yeah, so obviously, like we're still, it may end up just being too slow to be of any use and be dropped. But to me, sort of the main idea of doing this is to enable Xdp to be a transparent software accelerator for the networking path, so that you can just write an Xdp program that will magically make your network go faster while integrating with the stack completely, right?
So the idea is what? You move contracting into Xdp as a hash or what?
Yeah, so you create a new helper which using the unstable helper thing, which like you have the FIP helper today, right? You can look up into the FIP and get a result. Same thing, you pass the packet in Xdp, fill in a struct with whatever data, hit it up to contract, and it will return, this is the contract answer you have.
So I see the value of usability of existing tools, right?
Yeah.
I mean, this is not a performance improvement, right? Am I correct?
Maybe.
So you will accelerate some of the packets. If Alex can go back to the slides, I actually wrote it on the agenda. So you can say, I want to accelerate these specific fast path flows I really care about, and the rest, if I see something that needs fragmented IP packets, I'll fall back to the normal network stack. So I see, like Toga, that it is sort of accelerating part of the network stack, and we are playing in concert with the network stack. because if we have to implement everything, we'd be just as slow. But we can choose to implement only a small part of it. And then
but if you're doing a greenfield, I'm building a completely new networking thing for containers, for example. You should obviously do your own thing completely in BPF, and then you would have to implement all the features you want there, right?
Yeah, and in that sense, it makes a lot of sense for Cilium to do it. So.
Yeah, so we have some numbers in our presentation that we have 2 talks next week. I'll leave the last word to John, maybe, because we don't have much time left.
I think we're out of time. I just want to mention that there's an Hdp Dump Tool that there are links to.
Yeah. I'll copy all the links.
Yeah, it's most people. I think it was Jesse that added this topic, debugging Xdp programs. And I'm not sure, Jesse, you knew that there was this Xdp Dump Tool that can actually attach to existing other Xdp programs and read both the input and the output would also contain at the exit of the BPF program, give you the action that was taken. So you can actually capture or drop packets this way. Would that help you debug it?
It was just an idea. We were gathering ideas. Yeah, I know we didn't get to it today, but no, I hadn't heard of the Xdp dump thing. Maybe some other people on my team had and just hadn't relayed the information.
Yeah, but there can also be other ways of debugging. Yeah, so I just added my input that Xdp dump is a really great way of solving some of the customer problems that people have been complaining about. So we're out of time.
Thanks.
We didn't automatically.
Yeah, we're almost in time. I think we could take Q&A in the lounge zone if anyone would like to join.
Yeah, that would be great.
Yes, anybody still left? There is a 15-minute break, and then the next session will start. But this doesn't stop anybody else that doesn't want to be in those sessions from sitting in the lounge and chit-chatting.
Yeah. And I just want to mention with the Xdp dump, we actually want to integrate this into a TCP dump, and I can see on the people on the session list that Michael is there, which is the maintainer for TCP dump. So we would happily rip that code out and put it into TCP dump. So see that happening.
I've got one request, if I can pose it here. It's not exactly related to this thing, but related to how to calibrate the performance of the Xdp programs. So, for example, I was seeing it's hardly mentioned anywhere, whatever the patches people float in and the associated performance they put in, for the RX drop and other things. So most of the people are perhaps using their own methods to calibrate the thing. It would be a great thing if this can be kind of sort of standardized, or maybe some helpers can be provided so that all the performance can be measured on a similar platform, if it makes sense.
I think we can drop in. How do we go into the other sessions, Gemma?
I'm just going to end the session now, and then that will stop the recording. Just to let you know, unless you want the lounges to be recorded, they don't get recorded, okay? So it's private conversation.
Yeah. Thanks, everyone, for being here.
Yeah, thanks, everyone.
Thank you. Bye-bye.
Thank you. Bye.
Thanks.
Bye-bye. I'll let those thumbs up go up for a minute here, and then ending session.